why I'm talking about a digital alpha? Because Jim Keller was working, I think, EV6 processor, and Digital was also developing the Alpha EV8. And the Alpha EV8 was this 8 LU monster with a four-way SMT, guys. So, and because Jim Keller was the engineer there, and even he was not working on it as far as I know, but there might be some inspiration. That's at least it was never released. It was killed by the Intel because Intel bought the Alpha division from Compaq in 2001. They immediately canceled. Actually, the chip, the EV8 was, let's say, almost taped out because they scheduled the release to 2003. And so it was really close to the tape out. And because Compact was preferring the Intel Itanium, they get convinced by the Intel that the Itanium is the future. So they got cancelled uh, they decreased the development of the EV8. A lot of engineers left, and finally it was bought by Intel. So yeah, Intel is kind of evil here. So and Alpha EV8 with the 8 LUs, it's a pretty monster architecture, and it caused a kind of delay in the CPU development, maybe at least 10 years, probably 20 years, because we have a similar CPU in the Apple right now. So, and why I'm talking about? I'm just trying to prove that the Apple monster architecture is not the only one monster on the world, and there is actually more monsters. And we can also talk a little bit about the Nuvia Phoenix here, because this is the monster which is coming for the next year. And they released some new information. Let's talk about Nuvia Phoenix actually a little bit, because this is another monster in the CPU architecture, because they released some first info about their actually performance. Even it's a kind of range, it's wide range. This blue area is kind of wide range. But let's talk about they said they are about to 18 months to silicon, which means they are planning the actually the finished the product for end of the next year, which is pretty early. This is kind of the Alder Lake, Golden Cove, and Zen 4 maybe. So this is the competitor uh, for the AMD and Intel in this time range. And 18 months to silicon means that the production startup, the production start usually takes about 14 months. So actually they are about to like a couple of months to tape out right now. And they are probably finalizing the layout and maybe integrating the some input outputs like a PCI Express, but the microarchitecture is actually finished. And that's why they released some performance, because yeah, the microarchitecture is finished, and in the simulation, even they don't have a final silicon, but they can run any benchmark, any code, they can run through the simulation, and they can predict the performance like a 100% accuracy. The only difference to the real silicon could be some bugs and different frequencies and so on. But the architecture, IPC, and the performance is actually already known for their engineers. So Let's take this their picture seriously, and let's try to predict the performance. And I took this point as their target. Let's say it's not the highest point. The highest point would be somewhere here, like 2,300 Geekbench points. It's kind of optimistic, but I'm taking the 2,000 here somewhere, and the curve would be like something like this. Yeah, maybe. Of course, a little bit smoother, but uh, let's take a 2,000 Geekbench point. Let's try to calculate the IPC or some estimation. And actually, if we take a 2,000 Geekbench points and we will, let's say 3 gigahertz frequency, and we will do the same calculation like with the Apple cores and the other x86 I did. So Geekbench points divided by gigahertz, we will get pretty devil's number, 666 points per gigahertz. And you might also know that A13 had 502 points per gigahertz, which actually means that Nuvia will have a pretty high 32% IPC advantage over monsters A13 already. And our predicted score for A14 is 570, which is a really incredible number, a huge number. But you can see the Nuvia has a 666, which is 17% above Apple A14. So you can see next year Nuvia is going to be the new king of the IPC. And there is no wonder about it, because the chief architect, the main architect of these Nuvia Phoenix CPUs, this is actually the same guy who was developing, who was architecting those Apple. Yeah, this is the ex-Apple chief engineer who created his own startup, and he's now working for the Nuvia chips. So there is no surprise that the IPC will be super high. Actually, we would kind of think about Apple A15 next year. The competitor for the Nuvia Phoenix is Apple A15, and you can see it will be pretty close. A15 will be maybe, yeah, really close to the Nuvia Phoenix. So yeah, pretty expectable. And but the tragedy of the x86 you can see here when we compare to the Comet Lake. Comet Lake has a 276 in compared to 666 here. It's like a 2.4 multiplied IPC, so it's like almost 2.5 higher. So it's like plus 141%. It's like a more than double. This is really tragedy, and the end is the same tragedy. So I don't know what if you just imagine that next year they might be the Alder Lake and the Golden Cove, which is rumored to have a 40% IPC jump over the Comet Lake, which results in 386 points here. But still, if you compare the IPC of the Golden Cove, which 40% IPC, this is a huge jump, guys. This is a really huge jump, and AMD will have a really problems. AMD will really struggle in compared to Golden Cove. But compare the Golden Cove to the Nuvia Phoenix. This is the same time range competitors. Nuvia Phoenix will have a absolutely monstrous 72% IPC over the Golden Cove. This is absolutely devastating. So this is another evidence that for Apple doesn't make sense to stay with the Intel, because there is a bigger monsters that the CPU world is heading much faster than Intel and AMD do. And yeah, Apple is one of the leaders there, so it doesn't make sense to stay with something really slow here. And my estimation is that the Nuvia will be something bigger than an Apple. 6 LAUs. I I think they will go really wide, and they will have a 8 LAUs, because it's not simply possible to have a 2.5 higher IPC than the Intel Comet Lake without using really wide core. Actually, there must be a lot of execution units available per cycle. And another killer feature for this Nuvia Phoenix is it will be based on new ARM v9 instruction set. And because this is supporting, we already talked about it, 2048-bit maximum. Uh, they will use probably something more narrow, but the architecture is built for this wide monster. And of course, matrix multiplication, 10 times more performance. It's absolutely devastating. The Nuvia Phoenix is really monster, and it's monsters in compared to x86. But in terms of Apple, actually, in terms of ARM world, it's pretty. It's probably the best architecture will be, but it will be not really something devastation, because everybody from every vendor will have a in ARM will have a ARM v9, Apple, and also ARM Cortex cores. They are coming with ARM v9 next year actually. So yes, Nuvia will be new king, but the other ARMs will be pretty close. And just the x86 is totally outperformed, but really big way. So I'm really worried. I'm me as a AMD fan. I'm really worried about AMD, because Intel announced the matrix multiplication for the next year, but AMD is kind of silent. And if AMD doesn't catch the trend of the AMX, I'm starting to be really worried about AMD. Even they do really good job right now, it seems to be they have a really good time period, but I don't know. From since this since these numbers I analyzed, I'm starting to be worried about, especially about AMD actually. Yeah. So yeah, this is about the Nuvia. I call it the Godzilla because this is the when I talk about monster about Apple. Yeah, Nuvia is something bigger, so it's some Godzilla, or let's let's name it this way.